All right, let's start by learning the basics first. So let's do the definitions and theorems in geometry. Basic definition of a distance. How do we calculate a distance? The distance is the distance between two parallel lines is the length of a perpendicular segment between the two lines. So if you need to calculate the distance between two parallel lines, you need to just draw up a perpendicular, and the length of the perpendicular would be the distance between those two parallel lines. What is a vertex? A vertex is the point where two straight lines or rays meet. So in this case, we have the vertices as A, B, and C. A vertex is a singular point. If we have just one point, it's called a vertex. When we have more than one points, they are called vertices. Congruence theorem and postulates. Hypotenuse HL congruence theorem. What's an HL congruence theorem? If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two triangles are congruent. So let's take the right angle triangle. Let's make two right angle triangles. Triangle ABC and triangle EFG. According to this theorem, remember we are talking about a right angle triangle, so we must have a right angle here. If the hypotenuse and a leg, hypotenuse is the side which is right opposite to the 90 degrees angle. So we have AC and EG as the hypotenuse. If the hypotenuse and a leg of a triangle, now you can choose any leg. I'm going to choose leg BC and leg FG are congruent, then the two triangles are also congruent. So if I have been given that the hypotenuse of one right angle triangle is congruent to the other, I can write here AC is congruent to EG, and one of the legs BC is congruent to FG, and we already know that measure of angle B is equals to measure of angle F. Measure of angle F. Then these two triangles will be congruent. So we have triangle ABC would be congruent to triangle EFG. And what is the cause? What is the reason? It is HL congruence theorem. Hypotenuse leg congruence theorem. Side congruence postulate. If three sides of one triangle are congruent to three sides of the second triangle, then two triangles are congruent. This is known as one of the easiest congruence postulate. So you have to take two triangles. I will stick with ABC and EFG, and I will just change the markings to the sides. So I have now two triangles. I'm not going to call them right angle triangle, but what we have given, the corresponding sides of these two triangles are congruent. Remember, the word corresponding is very important. So AB is congruent to EF, AC is congruent to EG, and BC is congruent to FG. And how? This has been given in the postulate. This is the postulate. If it is given, or let's say you have to figure it out that all three sides are congruent, then triangle ABC is congruent to triangle EFG. All right, let's see the next postulate. Side angle, side congruence postulate. Now, please remember then that when you have postulates like side, angle, the letter in the middle of two similar letters, it means a lot. There's a lot of information hidden. What is that information? So we are working on SAS, which means that if you need to prove a congruence of two triangles, let's stick with the triangle ABC and EFG by SAS, then the angle between two corresponding sides should be also the same. So if I'm talking about two triangles, A, B, C, and E, F, G, and I have been given that side AB is congruent to side EF and side AC is congruent to side EG, then if I need to prove this congruency by using SAS, the angle should be in between those two sides, SAS. So if I want to prove this by using SAS, I need to talk about angle A. The other angles cannot work for the SAS congruency. So let's write it down. I'm going to try to write it down neatly here. And I'm not trying to erase the triangle EFG. So let me make the marks again. If two sides and the included angle, so let's say if we have been given that AB is congruent to EF and AC is congruent to EG, and the included angle, measure of angle A, or I can simply write angle A is congruent to angle E, then we can say that triangle ABC is congruent to triangle EFG by SAS postulate. Okay, I hope this information will come handy. The ASA, angle side congruence postulate. If two angles and the included side, please remember this is very important word. If two angles, let's try to draw two triangles, A, B, C, E, F, G. If two angles, let's choose any two angles. I'm going to choose A and C. So then the corresponding angles would be E and G. So if angle A is congruent to angle E, angle C is congruent to angle G, then if from the information given we can figure it out, or it has been provided to us, if the included side, which is AC, is congruent, don't forget to put the line segment mark, AC is congruent to EG, then we can say that these two triangles A, B, C is congruent to triangle EFG by what? ASA. Why ASA? Because the side is included between the angles. Remember, this side is included between the given congruent angles. I have seen a lot of confusion between ASA and AAS. In ASA, I'm going to say that again, it's hidden. The hint is hidden in the name itself. The side will be included between the two congruent angles. All right, let's look at the another postulate. AAS, angle side angle side congruence theorem. Now remember, when we say AAS, we are talking about two angles, but the side is not included between them. So let's say the information provided here is triangle ABC, EFG. We have been given that angle A is congruent to angle E. A is congruent to angle E, and angle B is congruent to angle F. Angle B is congruent to angle F. Now, what are the remaining non-including sides? So, if either of the non-including sides, what are the non-including sides here? We have AC and we have BC, and then here we have EG and we have FG. So, if one of the non-including sides is also congruent, we can find it out, or it has been given to us, then the triangles are congruent by AAS. So let's say I have been given that AC is congruent to EG. Now the information, I have 3 points here, first, second and third, two angles and the non-including side. I can say that triangle ABC is congruent to triangle EFG by AAS. You can rewind the video and see that when we were talking about ESA, we took the side which was included between the angles. So if this were to be proven by ASA, then the information provided should be that the included side, which would be AB and EF in this case, should be congruent. But that's not given to us. We have been given that the non-including side is congruent, so it would be AAS. We will also practice some more examples on the congruencies. CPCT, see, corresponding parts of congruent triangles are congruent. So if I have been given that triangle ABC is already congruent to triangle EFG, if we have been given that these two triangles are already congruent, then the corresponding parts will also be congruent. So what are the corresponding parts? AB, side AB would be congruent to side EF. Side BC would be congruent to side FG. Side AC would be congruent to side EG. And all the angles, angle A would be congruent to angle E, angle B would be congruent to angle F, and angle C would be congruent to angle G. That's our CPCT. Let's discuss few more theorems. Exterior angle inequality. The measure of an exterior angle of a triangle is greater than the measure of either of the two remote non-adjacent interior angles. Before we discuss exterior angle inequality, we should discuss the exterior angle theorem. This should have also been included in the document. So what is the exterior angle theorem? The exterior angle theorem for the triangle. The exterior angle theorem states that, let me draw a triangle and extend a side. The exterior angle theorem states that the measure of the exterior angle of a triangle when extended aside is equals to the sum of the measure of non-adjacent angles. What are non-adjacent angles? So if you look at the adjacent angle to angle 1, then the adjacent angle would be this part. Let me call it angle 4. The adjacent angle would be angle 4. So we are not including that. Forget about that. The exterior angle is the measure of the sum of the measure of two non-adjacent angles. If you look at different resources throughout the internet, it is also called as the exterior angle of a triangle is the sum of two interior opposite angles. So same theorem, just a different way of expressing in words. Now, once you know the exterior angle theorem, you can already guess that at every point, angle 1 would be greater than angle 2 or angle 3, not or, and. Because 2 and 3 adds up to give you 1, and that's where the exterior angle inequality will come in. So what is the exterior angle inequality? The measure of an exterior angle of a triangle is greater than the measure of either of the two remote non-adjacent interior angle, and my angles being 1, 2 and 3. Base angles theorem. If two sides of triangle are congruent, then the angles opposite to them are congruent. A, B and C. So if the two sides of triangle are congruent, so let's talk about this. If two sides are congruent, so if AB, line segment AB is congruent to line segment AC, then what are the angles opposite to them? The angle opposite to AC would be angle B, and the angle opposite to AB would be angle C. So if the line segments are congruent, then the angles opposite to them are also congruent. Remember that the converse of this theorem is also true, which is if the angles are congruent, then the sides opposite to those angles are also congruent. So if it is given that measure of angle B is equals to measure of angle C, or angle B is congruent to angle C, then the sides opposite to those angles, the side opposite to angle C is AB, is also congruent to the side opposite to angle B, which is AC. The triangle sum theorem. The sum of the measure of interior angles of a triangle is 180 degrees. Third angle theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles are also congruent. Okay. Let's make our triangles ABC, EF, G. So if two angles of two different triangles are congruent, then the third angle will also be congruent. So if angle A is congruent to angle E and angle B is congruent to angle F, then according to the third angle theorem, angle C will also be congruent to angle G. And if you have been given a question like this, you can simply say that from third angle theorem. So then angle C will also be congruent to angle G. The acute angles of right triangle are complementary. I would put this theorem as more of a common sense. If we take a right angle triangle, we know that one of the angles is 90 degree, and from the triangle sum theorem, which is right here, we know that angle A plus angle B or let me write measure of angle A plus measure of angle B plus measure of angle C should be 180 degree. Now if angle B itself is 90 degrees, let me substitute angle B for 90 degrees, and if you subtract 90 from both sides, you will get measure of angle A plus measure of angle C equals to 90 degrees. So you can see that those two angles will add up to give you 90 degrees, and when angles add up to give you 90 degrees, they are known as complementary. Okay, we got the exterior angle theorem. I was worried about that. So again, exterior angle, the measure of an exterior angle of a triangle is equals to the measure of an exterior angle of a triangle is equals to the sum of the measure of two remote non-adjacent interior angles. We just did that. So triangle A, B, C, and let's extend this line. Then I can say that the sum of the measure of an exterior angle, let's call it 1, is equals to the sum of measure of two remote non-adjacent interior angle. So measure of angle 1 is equals to measure of angle 2 plus measure of angle 3. And then we are about to wrap up with triangle classification. Triangle classification. Equilateral triangle. We know that equilateral triangle is a triangle with three congruent sides. So all three sides of the triangle are equals to each other. So AB, AC, BC, all three sides are congruent to each other. Now remember, we just did a theorem where we said that if the sides are congruent, then the angles opposite to them are also congruent. So if we apply the same logic here, then the angles opposite to these sides, angle A, angle B, and angle C would also be congruent, and their measures will be equal. So equilateral triangles also become equiangular triangles. Isosceles triangle, a triangle which has at least two congruent sides. So if we don't have three congruent sides, but at least two of them are congruent, then it becomes isosceles triangle. Scalene, where none of the sides are equal. Acute angle triangle, where all three angles are less than 90 degrees. Equiangular triangle, we just discussed that. Right angle triangle is where at least one of the angle is 90 degrees. And obtuse triangle is where if you have even one angle which is more than 90 degrees, then it goes into the obtuse angle category. So this is obtuse triangle category. So we can see that angle B is greater than 90 degrees. So this will be classified as obtuse angle. Those are some parts of the triangle. Hypotenuse. Hypotenuse is the side opposite to the right angle in a right triangle. This is also the longest side of the right angle triangle. The two congruent sides of an isosceles triangle. So if I have a triangle ABC where I know that AB and AC are congruent, side AB and AC are congruent, then it makes it an isosceles triangle, and those will be known as the legs of an isosceles triangle. So if let's say that you have just been given the information that the legs of an isosceles triangle are AB and AC, then this is enough information to understand that AB is congruent to AC. base, the non-congruent side of an isosceles triangle. So the third side, the remaining side, the side that no one is bothering to discuss about, that becomes your non-congruent side. If two angles of a triangle are congruent, then the side opposite to them are also congruent. We just discussed that. This has also been covered. So guys, I created this documents to put all the theorems together and all the essential vocabulary words in one document. I will try to attach the link of this document sometimes later in this week. But please let me know if there are any vocabulary words that I missed out on. And in my next video, we will discuss about questions based on the congruencies. So the congruencies that we will discuss in our next video would be, we will discuss all the congruencies, SSS, SAS, ASA, AAS, and HL. Please don't forget to like and subscribe my channel. I will see you later with another video. Bye for now.